Okay, here we go. Lesson 8.1. Lesson 8.1 is a graphing unit, and we are going to be graphing quadratic functions. We've graphed other things in this class. We've graphed linear functions. You don't have to write this in your notes, but linear functions are those functions that are like y equals mx plus b. We've graphed those. And then we've also graphed absolute value functions. Okay. And absolute value functions look something like that. Okay. And if you remember, this h and this k, they were called a vertex. Okay, and today we're going to graph quadratic functions. Quadratic functions have some similarities to some of the things that we talked about when we graphed absolute value functions. So let's dive in and see what happens when we graph a quadratic function. First of all, what is a quadratic function? A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. Okay, and we've seen these, we factored these in this last unit. And a is a number, b is a number, and c is a number, and then of course x is the variable in both of those. Okay, we've talked about parent functions before. A parent function is the simplest form of the function that satisfies the definition of the function. So when we talked about a linear function, the simplest form was y equals x. When we talked about the absolute value function, it was y equals the absolute value of x. And then when we're talking about a quadratic function, the simplest function is y equals x squared. Okay, here might be a new word. This is the word parabola. And parabola is the shape that results when graphing a quadratic function. And you're going to see what they look like. Okay, and then the vertex of a quadratic function is the highest, or sometimes we say maximum, or the lowest, or the minimum. Okay, point on the graph. Okay, and you'll see how that happens when we start graphing them too. Okay, the y-intercept is the point where a graph crosses the y-axis. It's the 0y point on a graph. We've seen that term before too. And then axis of symmetry is a vertical line that divides the graph into mirror images. And just like with the absolute value function, for a quadratic function, the axis of symmetry passes through the vertex. Okay. And then finally, the maximum minimum value of a quadratic function, it is the y coordinate of the vertex. Okay, so there's all the vocabulary words. It's important that you know them, but just like in the last unit, since we are doing online learning, okay, you don't have to memorize them for the next test. If we go back to a scenario where we're back in the classroom and you're watching this video back in the classroom, then yes, you will have to memorize this vocabulary. Okay, so graphing a quadratic function. Well, let's first look at the parent function. We're going to graph f of x. Remember, that's the same thing as y equals x squared. It's just fancier notation. We're going to graph y equals x squared, and this is the simplest quadratic function, so it is the parent function. Okay. So let's start. We're going to start in the middle. We're going to start at 0. And if I put 0 into this function, okay, I'm going to get 0 squared, which is 0. And you'll see in a minute why that was a good place to start. So I'm going to plot that point over here. There's 0, 0. Then I'm going to do 1. If I put 1 in there, okay, if I put 1 in there, I get 1 squared, of course, which is 1. And then if I put 2 in here, I get 2 squared, which is 4. And then if I put 3 in there, I get 3 squared, which is 9. So let's go ahead and graph those. So 1, 1 would be right here. 2, 4, 1, 2, 3, 4 is right there. And then 3, 9, 5, 6, 7, 8, 9. Let's go right about there. Okay, we'll say that that's 4, 9. All right, now let's go and do the negatives. So we learned in the exponent unit, if I'm going to substitute negative 1 in there, this means negative 1 squared, which is negative 1 times negative 1, which is 1. Okay, and I'll do the same thing with the negative 2. Negative 2 squared is negative 2 times negative 2, which is 4. And then, of course, negative 3 squared is going to be negative 3 times negative 3, which is 9. Okay, so let's go plot those points. Negative 1, 1, negative 2, 4, and negative 3, 9. So you should have noticed something about those, okay? Now if I graph this, connect all my points, there's that side, and here's this side, okay? Now a couple things that you should notice about the graph. First of all, it's rounded down here. Okay, so when you make your graphs, make sure it's rounded. It's not an absolute value. It's not a V-shaped. It is U-shaped. And this is called the parabola. Okay, what do you think this is called right here? Hopefully you're all yelling out, that's the vertex. Okay, remember the vertex is the highest maximum point or the lowest minimum point. Well, in this case, it is a minimum, right? Because it's the lowest point on the graph. There's no points below it. Okay? Now, the other thing that I want you to know, so here's my vertex right here. The other thing that I want you to notice is the symmetry. Okay? What if I go 1 away from the vertex, if I add 1 and I subtract 1, the values are the same. If I go 2 away, if I add 2 and subtract 2, the values of the function are the same. And same thing, if I add 3 and I subtract 3, the values are the same. Okay, that's because quadratic functions take on this symmetry. Okay, so my vertex is the point 0, 0, and my axis of symmetry, if you remember back to the absolute value unit, we abbreviate that AOS. My axis of symmetry is the line x equals 0. It's this line right here that goes through the vertex. Right? So This scenario that I just described here, this symmetry, will happen with every quadratic equation that we graph. They won't all have exactly this shape. We'll talk about the other possible shapes that they might have. Okay. Okay, so let's turn the page. So the equation of a quadratic function reveals a lot about the graph. Okay, so when the equation is written in this form, a with the x squared terms first, plus b with the x terms second, plus c, there's lots of information about what your graph should look like. Okay, so if the number in front of here, a, is positive, then the parabola opens up like an umbrella, okay, or a U shape, okay, it's U-shaped. Some people will say it's a smiley face. If you're positive, okay, you have a smile on your face. All right, if a is negative, the number in front of the x squared term, if it is negative, then the parabola opens down, okay, and is shaped like this. And of course, if you're a negative person or you're feeling negative, then some people call it a sad face. That's the way some people remember what it has to look like. So A tells us something. A tells us the shape. Okay, so the x coordinate of the vertex, there's a little formula that we're going to use to calculate it. It's the opposite of whatever B is. So if B is positive, we make it negative. If B is negative, we're going to make it positive, okay, over 2A. And also the axis of symmetry is x equals negative B over 2A. Okay, so that's the x coordinate of the vertex and the axis of symmetry. To find the y coordinate of the vertex, we substitute the x value that we calculated into the equation. Okay, that also may be the y coordinate, remember, is also the maximum or minimum value. Okay, minimum value. Okay, there we go. Okay, so that's what B tells us. That's what we use B for in this equation. We use B to help us find the x coordinate of the vertex and the axis of symmetry. Okay, and then lastly, what does C tell us? Well, C is the y-intercept. Okay, and if you think about it, that makes sense because we know the y-intercept happens, okay, when x is 0. It's going to be somewhere along here. And if I put 0 in here for x, both of these terms are going to go away, and I'm left with C. Okay, so let's just do a quick sketch of like 2 other parabolas. I'm not going to do them from equations. I'm just going to sketch them, and we're going to label all the parts. Okay, so I'm going to put the first one over here and look like this. Okay, now notice I did a rounded bottom and not a pointy bottom like an absolute value function. It would have a rounded bottom. So there's my parabola. Hopefully yours looks a little neater. It's hard to write off to the side like this. Okay, this point right here is the point 0C. Okay, if I were to look at my equation, that would be the point 0C. This point down here, the lowest point, this is my vertex. And the way that you find that from your equation is negative B over 2A. That's my x coordinate. And then I take the function and I put negative B over 2A in there wherever I see an x. Okay? And there's something else we know right here. This would be my axis of symmetry, and it's the equation x equals negative b over 2a. Oh, you can't see that. I see that now. Okay, so let me move it up. Move that over there. Okay, so there's my axis of symmetry right there. Back out. Might be a little easier to see things. Okay. And then one other thing that I know. We know in this scenario, we know that A is positive because of the smile. Okay? Again, you can't see that. All right. So they don't all look like that. There are some parabolas that we're going to graph, and they might look like this. Okay, they might look like this. So here we go. Here's another parabola. Okay, and if I continue this down here, okay, there we go. All right, so this point right here, this is the point 0C, right there. This right here, this is the vertex. That is the point. Negative b over 2a and f of negative b over 2a. Okay, this would be my axis of symmetry. And it's the line x equals negative b over 2a. So everything is the same. The only thing that's different over here with this parabola is we know a is negative because of the frown. Okay? Okay, so let's actually go and look at some other equations and actually graph those other equations. Here we go. Okay. So here's our first equation. X squared plus 4x minus 12. So the first thing that we should do is identify what A, B, and C are because they tell us so much about our graph. So first of all, A is 1, right? There's an invisible 1 in front of there. B is positive 4, and C is negative 12. Okay, the next thing we want to ask ourselves is, what is the shape of this going to be? Is it going to be a smile, or is it going to be a frown? Well, it's going to be a smile because A is positive. Okay, we know that because A is positive. What is the y-intercept? Well, the y-intercept is going to be the point 0, negative 12 because C is negative 12. Now the next thing we need to do is figure out what our vertex is. So we're going to use that formula, the opposite of B over 2a. Notice how I say that. I say the opposite of B. Okay? So if I look in here, the opposite of B, well, B is 4, so the opposite of B is negative 4 over 2 times A, which is 1. Okay? And so that's negative 4 over 2, which is negative 2. So that's the x-coordinate of my vertex. Now I got to find the y-coordinate. So y is going to be what I get when I put negative 2 in here for x. So watch what I do. Negative 2 in parentheses squared plus 4 times negative 2. Notice that whenever there's an x, I'm putting it inside parentheses, okay, because that's going to help me when I go and do this on my calculator. which I'm now going to get out. Okay, so here's my calculator. I'm going to now put that into my calculator. So let's turn that on. So negative, the parenthesis, -2, and then remember this little caret squared, is 4, plus, and then I'm going to do 4 times -2. And then I'm going to subtract 12. And I get -16. Okay, so my vertex is -2, -16. Okay, axis of symmetry. My axis of symmetry, x equals -2. This number and this number will always be the same. All right, let me move my calculator aside. Now, to get more points, I'm going to do my table of values. Okay, so here's x and f of x. Okay, of course, this is also y. They're the same thing. All right, so I'm going to put my vertex right here in the middle. -2, -16. All right, and you have to come up with 5 points in your table. Okay, that's always going to be the requirement. But here's the beautiful thing. You only, once you have your vertex, you only need to calculate 2 more. And I'm going to show you why. I'm going to pick 0. 0 is always a great point to pick, okay, because it's easy to do the calculation. If I put 0 in here, I know I'm going to get -12. Okay, and I knew that from right here, so I really didn't even have to do a calculation. Now, remember what I said. From here to here, I added 2. Okay, from my vertex. Okay, I added 2. So now I'm also going to subtract 2. Okay, and -2 minus 2 is -4. And I know since this parabola is symmetrical, okay, I know that this has to be -12 also. This and this have to match. Okay, now I'm going to do another one. I'm going to do another point. It doesn't really matter which one you do. You could pick anything. Maybe I'll go 2 more away. Okay, so let's try that. I'll just go +4. You could have gone, 1 more. You could have, sorry, that's not right. This is 2. You could have gone to 1 next if you wanted. And I know, okay, whatever I get when I put 2 in is the same thing I'm going to get when I put -6 in. Okay, so let's go ahead and figure out what happens when I put 2 in. Okay, so y is going to be equal to 2 squared plus 4 times 2 minus 12. Well, 2 squared is 4. 4 times 2 is 8. Okay, and 4 plus 8 is 12. And then 12 minus 12 is 0. Okay, and so then this would also be 0. All right, so let's go ahead and put those on our graph. Sorry, I got distracted there. It's easy to get distracted at home here. Okay, so -2, -16. So in order to fit that on my chart, okay, each of these are going to be 2 apart. Okay, so -2, -4, -6, -8, -10, -12. So there's a point, 0, -12, -14, -16, and -2, -16. Okay, so here's 1, 2, -2, -16 down here. Okay, and then here is 0, -12, so I also know -4, -12 is on there. Okay. Okay, and then let's see, 2, 0, 1, 2 zeros on there, and so -6, 0 is also on there. Okay, so there's my 5 points that I need to make my parabola. So here we go. There. And there. And notice when I came down here, I did curve. Please make sure that you're drawing curves down here as best as you can. Yeah, here you go, Mrs. O'Toole. There you go. Okay, so there's my graph. All right, so let's do one more together. We're going to do another one together, and then we have, I think, 4 that we can do together once we get online. Okay? Okay, so here we go. Let's do the next one. So first thing we're going to do is we're going to identify A, B, and C. So A is -2, B is 4, and C is 2. Now since A is negative, we know this is going to be a frowny face. And we know the y-intercept is 0, 2. So let's go ahead, figure out what our vertex is. So our vertex is -b over 2a. I'm going to say that again, the opposite of b over 2a. So the opposite of b is 4, and then 2 times -2 is 4 over, I'm sorry, let me slow down. The opposite of b is 4. The opposite of b is -4. 2a is 2 times -2. So I get -4 over -4, which is +1. Okay. Okay, and so f of 1, okay, if I put 1 in here, I get -2 times 1 squared plus 4 times 1 plus 2. Well, 1 squared is 1. 1 times -2 is -2 plus 4 plus 2 is 4. Okay, so I just figured out that my vertex is the point 1, 4. And then, of course, my axis of symmetry is x equals 1. All right, let's go to our table of values. X and y, and I'm going to put my vertex right here in the middle, 1, 4. All right, so I'm going to go backwards 1 to 0, and I know at 0 it's 2, so I know if I go forward 1 to 2, it's also 2. Okay, now I'm going to calculate, what if I go forward 2? I'm at 3, and if I go backwards 2, I'm at -1, right? All right, so I'm going to actually calculate f of 3. So f of 3 is going to be -2 times 3 squared plus 4 times 3 plus 2. So that's going to be -2 times 9 plus 4 times 3 is 12 plus 2. So let's see, -18 plus 12 plus 2. That's -6 plus 2 is -4. So at 3, we know that the y value is -4, and at -1, we know the y value is -4. All right, let's go ahead and graph this. We know this is going to be frowny face. So let's see, 1, 4, 1, 2, 3, 4 is right there. 0, 2, right there. 2, 2, right there. This is going to be a skinny one, okay? And then 3, -4, 1, 2, 3, 4. and then -1, -4. 1, 2, 3, 4. All right, so there is our parabola. Just make sure that you do a curve at the top and connect your points. And there's the parabola. All right, we're going to stop there. You're going to ask me whatever questions you have in class, and we're going to finish the other 4 examples together in class. Okay, everybody, see you soon.